Our next shuffle is shuffle 35, the bottom row on the left. This is a judicious Klondike. So this begins the same as the previous two shuffles. The only difference is that we will be dealing out pairs into 4 piles, and then we will consider different ways of stacking those piles, which will result in different permutations. Okay, so let's go ahead and derive the permutation for this shuffle. So we begin with our ordered packet 1 through 8. So how this works for the judicious Klondike is we take the top and bottom off as 1 and we put them into a first pile. So like pile 1. Top and bottom off as 1 into a second pile. Top and bottom off as 1 into a third, and then the last 2 go into their own pile as a fourth pile. Now the stacking is as follows. 1 goes on top of 2, that set of 4 goes on top of 3, that pile of 6 goes on top of 4. So in other words, we just stack from left to right. That's all that means. Okay? So what is the new ordering of the cards once we've performed all of those actions? Well, let's take a look. It's 1, 8, 2, 7, 3, 6, 4, 5. So in Cauchy's 2-line notation, we obtain the following. The top row is always 1 through 8 in our case. And now we have 1, 8, 2, 7, 3, 6, 4, 5 for our new ordering. This can be converted to cycle notation as follows. 1 goes to 1, so it's a fixed point. So whatever begins in position 1 will stay in position 1 or be returned to position 1 once the shuffle is completed. 2, what happens with 2? 2 goes to 8, so we have an arrow from 2 to 8. 8 goes to 5, so we have an arrow from 8 to 5. 5 goes to 3, so an arrow from 5 to 3. And 3 returns back to 2, completing a 4 cycle, we call it. What else? 4. 4 goes to 7, so we have an arrow from 4 to 7. And then 7 returns back to 4. So this completes what we refer to as either a 2 cycle or a transposition. And finally, 6 goes to itself, so it is a second fixed point. It's also called a 1 cycle. Color coding, these 8 values, we obtain the following. Recall that the 2 sets of position values important to us in the study of Bessey sequences are the following. Positions 1, 4, 6, 7, which are color-coded black, and positions 2, 3, 5, 8, which we will color-code red. If after completing a shuffle, the cards that began in these positions, 1, 4, 6, 7, return to these positions in some assignment, they may have been permuted among themselves. Similarly, if the cards that originally began in positions 2, 3, 5, 8 get returned to those positions, then we say that the Bessey sequence that we're working with has been preserved. Whereas, if what begins in positions 1, 4, 6, 7 get moved to positions 2, 3, 5, 8 in some assignment, then we say the sequence has been inverted. So we're looking at an inversion of the sequence, and it's denoted as follows. So we see here that black 1 goes to black 1, red 2 goes to red 8, which goes to red 5, which goes to red 3, which returns to red 2. Black 4 goes to black 7, which returns to black 4, and then black 6 goes to itself, returns to itself. It's a fixed point. So we see that each value gets sent to a value of the same color. So what that will mean then is the Bessey sequence we're working with will be preserved. The sequence form of that Bessey sequence will be preserved. So no inversion has occurred here. And we can demonstrate that using our Bessey sequence 1001, 0110 as a starting sequence. And we'll perform this shuffle, and we should get this exact form back once the shuffle is completed. So let's go ahead and just verify that. Okay, so this is the judicious Klondike, where we're setting out pairs into 4 piles. So the top and bottom come off as 1 into a second pile now. Top and bottom off as 1 into a third pile. And then the remaining 2 cards become a 4th pile. The stacking, as indicated here, is from left to right. Now what we're expecting to see is the same sequence form 1001, 0110. And is that what we get? 1001, 0110. So this sequence form has been preserved by the judicious Klondike with stacking from left to right. And I have a note up here for those who have studied Principles in the Hidden Structures online course, that this judicious Klondike is a very special shuffle in the case of 4N cards. So that would be 4 cards, 8, 12, 16, 20, 24, and so forth. For packets of those sizes, this shuffle will convert what we call a 2-cycle in the study of cyclic and mirrored structures. It will convert that structure type to a mirrored structure, and then convert that to an AMP structure, and then convert that back to a 2-cycle structure. And it is extremely rare to find a single shuffle that will complete this cycle. Normally, only certain shuffles can be used to go from one structure type to another. But here we have found a shuffle that works for the completion of that diagram. So let's go ahead and look at the Bessey shuffle diagram for the judicious Klondike, in which we're stacking left to right. So this is shuffle 35. So as already indicated, we do have 2 fixed points, 6 and 1. Objects in those positions are returned to those positions. And then because we have a transposition right here, 4, 7, that means we should expect to see a double arrow between 4 and 7, which we do. And then we have a 4-cycle here. 2 goes to 8, which goes to 5, which goes to 3, which wraps around to 2. So if we go down here to 2, we should see an arrow from 2 up to 8, which we do. An arrow from 8 down to 5, and then an arrow from 5 to 3, and then an arrow straight up to 2. And that completes the 4-cycle. We also say that those 4 values, 2, 8, 5, 3, constitute an orbit, since they are values that simply get moved around among themselves according to the direction of the arrows in the diagram. And we also have a smaller orbit of just 2 objects, 4 and 7. And then we have 2 very small orbits, one consisting of just the number 1, and another orbit consisting of the number 6.